I've spent most of my career in developer tooling and infrastructure management in one form or another. I started out working in data centers, schlepping around servers, and it was sort of dreadful. Ended up automating myself into the office just so that I could be with humans instead of machines. That was nice. And sort of just kept doing that, kept at it. So I've been, working on, I've worked at Puppet, worked on Puppet, and now working on Kubernetes at Microsoft. This is Taylor.
Yep, I'm Taylor. I have a kind of similar backstory to Jordan. I was once upon a time doing stuff in a data center, have that memory of pulling out a live drive from a server and having it wrench your arm. And so I've also kind of went from there to being more towards a developer. I started more towards Intel, and then was at Nike with Jordan, and like he said, now we're both working on AKS at Microsoft. And so just a little bit, so well, why listen to us about these ideas we're gonna give? We've collectively built various application platforms for different kinds of enterprises with Kubernetes over the past few years. So this talk is just a combination of what we've learned along the way and sharing some ideas and conversations that we've had around some misconceptions about what Kubernetes is for and what you can do to really leverage Kubernetes.
So meet the app developer. He's a good app dev, a good, responsible, competent app developer. Writes memory leak-free C++. So generally, probably an app developer cares a fair amount about the business, at least what the software does, hopefully what the software does, and not only how the software itself is constructed. It's sort of a blend, right? They probably have a background in the business that the organization works in addition to some kind of computer science or tech background, but it's cross-functional. And this is a really good thing. Like, we should have more people that work cross-functionally, that understand humans and are able to translate that into machine talk. And ultimately, this is why we're all here, right? We do things that help humans. We don't just help machines sort of satisfy themselves in infinite recursion. So they're what make us all money. It's a really good thing. They're sort of the lifeblood of the tech organization. But this is all too common a story when they get into deep waters. Kubernetes is particularly deep waters. It demands a lot of time and attention. Half-hearted efforts tend to result in this type of chaos. There's a fish on the deck somehow, tentacles encapsulating the boat. It's a real mess. For all of you that raised your hands as app devs, I suspect maybe you have felt this at one point with Kubernetes, one way or another. Oh, I'm seeing some nods, yeah. We've all been there. And so ultimately, we would attribute this to the idea that Kubernetes doesn't hide very much from you. It exposes the computational primitives underneath these systems that we deal with. And if you don't have a solid understanding of those primitives, then Kubernetes doesn't do you a lot of good. It puts a lot of control in one place, and it makes those primitives very obvious, very messy. It's a very sharp knife. So primitives, let's define that as, let's say, processes, files, kind of these system-y things that maybe app developers in previous years didn't stumble on every day. So simple questions become difficult to answer. Like, why are my pods evicted sometimes? Should I worry about that taking down my app? How do I just get all the logs? They're not just in var log on one server anymore. Like, how do I get all the logs from my app? Is it normal that my app is running as root? Like, should I be worried about that? And then how do I kind of roll out a change that only affects certain users, right? Now that we have all of this newfound power, we sort of start to push the boundaries, and the boundaries get particularly difficult. So it's hard for app devs because they need to understand Kubernetes as an abstraction system in addition to what Kubernetes abstracts, which is a lot more complex than Kubernetes itself. So why bother? Why bother? Sometimes I don't know. I think our argument is that Kubernetes justifies its own weight. It's big, it's complex, but it models something that's even bigger and more complex. And by kind of centralizing control of these computational primitives, we gain a great deal of efficiency. We're able to, in kind of practical terms, start and stop many processes at one time, right, at sort of a primitive level. We can easily modify files across thousands of nodes. Like, these things that used to be rather difficult have become trivial, and that's a big deal. So having those primitives exposed in a convenient way is worth a lot of the baggage that comes with it. But on top of that, we do get some higher order primitives or abstractions on the Kubernetes primitives. Deployments, horizontal pod autoscalers, ingress resources come to mind. There's more. And these are really where the value is at, right? Because someone wrote the deployment controller. And so I don't have to worry about rolling app deployments anymore. Like, that's terrific. So ultimately, it's those higher order constructs that really bring the value. But they also bring additional complexity. And so there's this kind of dance between the complexity of the primitives themselves and then the added complexity of the higher order primitives. And ultimately, the benefit that we get from those higher order primitives is a sense of industry standardization, right? Even if you individually aren't feeling the benefit of a deployment resource, we all kind of agree on what a deployment is. And that's a big deal for us as an industry. So the takeaway here in plain terms is that Kubernetes is really hard. It's worth it. It's hard because the systems that lie underneath are hard. So it often makes sense to specialize. So meet the platform dev, i.e. DevOps engineer, SRE, infrastructure engineer, new school, sysadmin, what have you. They're pretty hip. Like, they run Linux on their laptop. They write Go. Generally, they're into technology in a way, right? They're probably not as interested in the business as an app developer would be. And for a reason, they're specialists in infrastructure software. Usually within an organization, they're responsible for providing a platform to app developers one way or another. The boundaries of that relationship can be organic or can be somewhat siloed or harsh. It sort of depends on the situation, but you see a lot of both. Sometimes they're even embedded in app development teams. It's not a bad idea. So this is, all things considered, we've sort of seen this come in various waves in the industry, right? The ops dev divide, and then that breaking down and sort of starting to kind of embrace some of the splitting again. Well, we're making a positive argument for this. Of course, there's lots of caveats, but specialization in infrastructure tech, specifically around Kubernetes, it's not a bad thing. It's a very good thing, because ultimately it frees up the app dev to do the human-machine translation that makes us all, our salaries at the end of the day. It's a very good thing. So here, I'm just going to read this one verbatim. Responsible Kubernetes users limit their own options by abstracting away what is constant within their organization. If you take nothing else away, take this. This is the job of a specialist. So building an opinionated platform means that at the end of the day, the platform engineer, the infrastructure engineer, what have you, is limiting the options of app developers that maybe don't know better and maybe don't need to know better. Heroku being a terrific example, right? Greatly limited options, but there's a freedom that comes with that. Important caveat is that the complexity doesn't go away just because it's hidden. It falls on another person. So someone still has to manage that fleet of nodes that has a tendency of going away. Or, I'm going to work in a donut here. We're going to work it in. OK, so let's say I have a donut. It's on the table way back there. And it looks like a perfectly fine donut from here. It looks delicious. But my human perceptive mechanism is filling in a lot of gaps. I probably can't really see the detail of the donut. I just kind of think, that's a donut, and I take the donut for granted, right? That's a good app developer thing. The donut should be taken for granted. But what if I walked closer and the thing was actually covered in bugs? Like, let's say ants. It wouldn't be, wow, this is an overwrought analogy. We're making it work. The infrastructure engineer's job would be to stand at that donut and to pick the ants off of it. And then I would pick up the donut and eat it. There we go. So the perils of this relationship are many, and ultimately, if you're in a position of either the app developer or the platform developer in this situation, you should sit down and talk and actually work things out in an organic way. There's probably a lot of pain on both sides of this relationship. So having kind of a human element, getting together and determine the bounds of that specialization, determine how you can best work together. This is a very deeply human pursuit. It's really hard. The responsibilities need to change over time as the tech changes over time. And ultimately, that's uncomfortable for a lot of organizations. So this is a delicate dance, but we believe that it can be a productive one.
And that brings us to the nitty-gritty details. So we've been talking kind of a little bit more abstractly about the different things that you should consider. But if you're a platform developer going to listen to an application developer, what are the actual things you should listen for? First off, you really need to understand their current ops practices. How do they release their app? Where are they developing? Are they developing on local machines? Are they sharing a server somewhere? There's multiple different ways that people are developing their apps. And how do they test those apps? Is there unit tests, and then do they have a specific fleet of servers that they run tests on? There's many different details that you need to understand about how they run their ops currently with an application, even if they're not the ones doing the ops. The next thing is learning about their apps. You have to ask questions like, do you care about low latency or high throughput? Do you need high availability? I mean, that sounds kind of like a dumb question. Everybody wants high availability. The answer actually is no. Most people don't care for some of these, especially like internal apps. If it goes off at 10 o'clock at night and most of the business isn't on, nobody cares. Speaking from experience. And the other question you ask is, where are they storing their state? Are they storing it in some remote data store? Are they storing things locally or with some sort of attached disk? And then ask, what technologies do they use? What are the languages they use? What are the frameworks they use? Those are critical to identify for some of these abstractions that we'll go into later, some different things that you can try. You have to understand what technologies are in use by the application developers. And then another one that's really interesting is identifying their business requirements. And some people go, wait, but we have our own business requirements and they have their own. But you have to know what do their bosses expect and how are they measured? Why does that matter? A good example of this is compliance, that wonderful word. If you work at a large company, you probably have some sort of security checklist or checklist of things you have to get done or approved before an app can release or certain changes can be made. Those are the kind of things that if you understand what their process is, you can abstract that away from them entirely. And it makes both sides happy. It makes those wanting the compliance to have just something automated so it always happens, and it gets rid of that from off the app dev's shoulders. Now last and most importantly is really a combination of the previous three and a few more points, is you have to understand how they think about their systems. One of the best exercises you can do if you're a platform developer is sit down with the app developers you're supporting, and app developers be willing to do this. And you go in and you sit down together and you map out what does the system look like. Everybody has a slightly different mental model, and getting that out helps you understand what you can make easier and what you can abstract out. You can also start understanding what legacy things could you make easier for them. Many times when people are starting to move their apps into Kubernetes, it's something more legacy. And then you have to start considering how they're doing things within their systems, like monitoring and tracing and logging. What kind of view do they need into their apps? And what kind of information do they need to gather? Because some of it is something that maybe only you're going to use as a platform developer, but other times it might be something that they want to see. So let's get even a little bit deeper. I'm sorry for the terrible Java joke for the title of this. But what are the things you need to consider when you're implementing something that an app developer needs? So I'm going to be going into some Examples that we've seen of how you can abstract away and make a platform built on Kubernetes that developers can actually use. But this is something that applies to all of them. Like with most things, the devil's in the details. And so understanding the implications of these details is a platform developer's job. So you have things like a service and an ingress. You have to decide, are you using a service or are you using an ingress? If you are using an ingress, which ingress controller are you using? What kind of classes of ingress do you want to set up and why? How are you going to route them? How are you going to provide the high availability for them? Those are all things you have to consider if you're doing a platform. And you have to figure that out for networking. Then you also have things like RBAC and policies. You have pod and network security policies. You have RBAC rules. How much access are you granting to an application developer or to other types of people who need to view things in the cluster? Then how do you handle things like deployment and scaling? So if you have a deployment, what is your update strategy? What are the ways you're going to run your containers? All those settings that you see on a pod spec, you have to figure out each of those details. And then you have to do things like limit rangers. Like if you have multiple shared resources, you have to find a way to make sure that you don't end up with the noisy neighbor problem. All these things are the kinds of details that app developers generally don't want to handle. And that's why, yes, it was a superlative title, but we actually believe that. Kubernetes is not for developers. These are the kinds of things that they shouldn't have to worry about when you're developing an app, when this lifeblood of an organization is developing it. So let's give some examples. What do you do as a specialist if you're a platform dev? One thing to understand before I dive into this is that Kubernetes is fundamentally a resource-oriented system. So any interaction involves one or more API resources you have to work with. The way to protect a developer from Kubernetes is to template or generate the API resources for them. When you boil down all the options we're going to talk about, that's eventually what it comes down to. And if you're a platform dev, you generally think, okay, how can we do this with software? So we're not just like running these things manually. So I'm going to walk through some practical examples. Now, each of these examples could really be their own talk, so we're going to kind of breeze through them. But these are based on real things we have done and seen in the different places we've worked. So first off, this is we're going to start with like the lowest level of abstraction to the highest level of abstraction. And first off, you have scripting. And let's face it, just at the beginning here, you'll likely use some sort of scripting no matter what option you choose. Like we've all written bash. We all have to write bash, and generally a make target. That all happens. That will still be there. But this is more of the using scripting as your main thing for deploying to Kubernetes. Now I'm curious, how many of you have used scripting for your Kubernetes setup before, either currently or before? Okay, so a decent amount. This is how I actually started with Kubernetes. Scripting is a really good option for you if you need like a total flexibility of everything, and you should only do it if you have good scripting practices at your company. If you don't, once again, from experience, it quickly becomes a rat nest, and you just don't want to have to manage that. And just a note of warning, if you do go down this route of scripting, just be careful not to end up re-implementing something like Helm underneath the hood. Like you just end up templating stuff with environment variables, you just might as well use Helm at that point. But as you can see here on this slide, we have how the app dev would interact with this method and the platform dev. And an app dev would just be invoking a script either locally or with the script runner, Jenkins, Circle CI, Concourse, name it. I guess I work for Microsoft, Azure DevOps. And so any of your script runners, they have some way to invoke it. And then as a platform developer, you define those scripts and the arguments that it takes, and you get to choose the platform that it runs on. So that's what you would do from a scripting side. Now, I've done this before a little bit with Ansible and Bash, and it turns out okay, but eventually you kind of run into things where you want to move to something more evolved. And that's where we get to Helm. So just a caveat, I am a Helm core maintainer, so that makes me a little biased here, but how many of you have heard of Helm? Okay, good. If you haven't heard of Helm and you're new to Kubernetes, you better go check it out. How many of you use Helm in your Kubernetes stuff? Okay, so a large chunk of you. Helm is the Kubernetes package manager, and the idea is that it allows you to share and reuse applications that run in Kubernetes. And so like you could, with whatever apt-get or whatever, you could say apt-get install whatever software, we wanted to do that for Kubernetes. And so Helm has that, and you can install some amazingly complex systems with just a simple command. You can do something like Helm install Elasticsearch. And instead of having to spin all that up yourself, it has everything already predefined and some knobs you can configure with something called the values file. It also provides some basic lifecycle management called hooks You have pre-install hooks, post-install hooks, pre-update hooks. All these things can run to help do specific things for the lifecycle of the application. But it's limited in some senses, and the values file can also become a bit constraining because eventually you end up just exposing all the same command line flags that your application needs to start up as a Helm value. Now, Helm is a really good option if there are many common pieces of software that all your teams use. This is things like security tools that need to be installed, logging, specific database implementations. All of those things are really good for sharing. You only have to write it once, and then everybody can use it. You also have to recognize that there's still a lot of knobs here, and people are still interacting directly with Kubernetes. Your developers will still work directly using kube-control to check on the status of things. This is OK if your developers want that, but really, if you're trying to abstract away Kubernetes, it's better to try to hide away as much of that as possible. Now, something with Helm is that it gets people excited. It really does help people understand Kubernetes, because I mean, the first time I used it, it was like when I could do Helm install Elasticsearch or Helm install like MariaDB, it was like mind blown. And so it really is a good opportunity to get people into Kubernetes, and it made that reuse really easy. But you'll find Helm wasn't meant to be a lifecycle management tool of your application. That's not its primary use case. And so sometimes you start running into where it feels a little bit too simplistic for you as you're trying to do something more complex. And eventually you might end up forking all your charts and defining every variable. But the thing is it is still a great model for the app dev, as you can see. They can manage the releases and they can get the state of their app, and then the platform dev just has to maintain that chart. So next one is a CRD and controller. So does everyone know what a CRD is, a custom resource definition? Yeah, OK, I'm making sure. How many of you have done something with a CRD and a controller model before? OK, so a few. This is a lot less. Now, a CRD is, like I said, a custom resource definition. Allows you to define whatever type of structure you want and leverage all the Kubernetes APIs. So you can define a custom object, and then you can have RBAC rules that apply to it, and it's handled by the Kubernetes API when you submit it. And then you generally have a controller that handles this on the outside and watches for changes in that object and then does something for it. What this does for a developer is they manage the application now by instantiating and modifying a version of that resource. So instead of having to deal with deployments and services and HPAs and ingress and yada, 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 now it's just one or two custom resource definitions that they have to know. So it greatly reduces the space of what you have to use in Kubernetes, at least from an app dev side. And then a good example, I guess, of this is the etcd operator, which is one of the longer existing operator/controllers that's out there. And it's a great example of how you can take something that's really complex. If you've ever spun up an etcd cluster before, you have to make sure you spin up things and discover everything properly. What it does is it reduces it to a single definition that you can submit, just that says etcd cluster. And you can specify a number of nodes and the role if you want to have backups and if you need to restore from a backup, and it handles the entire life cycle of that application. This is a great thing for app developers because it just reduces it to something so much smaller. And especially if you have some common things that happen for every single one of your applications, it's easier just to wrap it and take care of that for your developers. So last, but probably the most highest abstract. This one is a little bit crazy. This is a custom API. So I'm just curious, has anyone made a custom API on top of Kubernetes that they've used their business? OK, yeah, see, I get about, I think I saw 4 or 5 hands up. We don't get that many. This is something that is a little bit more intensive, but can provide a lot of power, I should say. As you can see, the idea behind a custom API is that the application developer would just have to call the API that's wrapped around it to create the application. And then they give some sort of artifact that they have to deploy, whether that's a container or a binary or whatever it might be, to deploy their application. Then from the platform dev side, they have a lot of other work because they have to define the API, and they write the controllers and the business logic around running the application. It's going to provide a very opinionated interface, and the users don't even have to worry about Kubernetes at all. You could switch this out entirely underneath for something like Nomad if you wanted to. Oh my gosh, you mentioned Nomad in a Kubernetes talk. But it doesn't matter. You can swap it out underneath for anything that you want to. It just always has that same point of abstraction for your users. The The big disclaimer on this is that you should not do this unless you are probably a big company with a very specific need. When we've done this before, this is something where we could identify that many of the users had a common language or a common 2 languages and frameworks that they could all use. The example that we've had before is that we wanted to completely hide Kubernetes from our developers, because as we sat there and talked about, okay, what do our developers want? They just wanted the place to run their apps. They didn't care. Containers was relatively new at this time for the organization we were in. And so the idea we thought was, if, for example, Java, if everyone's doing Java, then why not just upload a jar? People don't even have to worry about containers. And that would give them a highly available auto-scaled app with a TLS cert and a domain name, with a way to view some basic logs and system metrics, and then also conform to all the API standards that already existed for the organization. So as I said, this is very, very specific. It's probably overkill for some instances, but if you have a very homogeneous use case where it's 1 or 2 languages and a few frameworks, this can actually be a real benefit for your developers. And ultimately, that's what all these are. These are examples. You can implement these kind of things in any way, but you have to know that your developers are not going to want to have to interact with Kubernetes all the time. There's some that do, and if you do, that's great. Have fun with Kubernetes. It's really fun to do that. That's how I started with it. But what I have seen, I know that Jordan has seen, we talked about this as we wrote this talk, is that most of the people we see, they don't want to have to interact with Kubernetes a lot. They just want somebody else to manage it for them. So Kubernetes is not your developer tool, but you can use it to build powerful developer platforms. So with that said, we have some time left over for questions. I'll try to repeat it if you yell it so anyone can hear it, but I love these moments. It's like we either bored you all to death or we explained it really well. Okay, awesome. So just one thing, just a big thanks to Emily, Jordan's wife, who drew all these things. So if you're interested in having some more drawings, you can always reach out to her. So I think that's it. If there's no other questions, and thank you very much.
Thank you.